Hello students, I am Rohitash Singh Chohan and I am here for discussing the topic of diffusion and oxidation. So far in this topic we have discussed about Ficks first law. Now we are having the continuity equation and Ficks second law. The continuity equation forms the basis of continuum approach for particle concentration as the variable. The equation can be mathematically written as the first equation del n xt upon del t is equals to dn xt by dt minus divergence f. In above expression, let the left hand side represents the rate of change in concentration. The divergence term represents the net outflow or outgoing flux of the particle. In one dimension, the equation is del n xt upon del t is equals to minus del f upon del x. The electric current density Je due to electric field E is given by Je is equals to Qi n mu E. Qi electronic charge, n is the concentration, mu is the mobility. So the flux density for donor and acceptor can be written as nd mu d E and minus Na mu A E. The two equations showing flux density of donor and another one flux density of acceptor. The net current density is given as J is equals to diffusion current plus drift current. So the diffusion and diffusivity flux density can be expressed as F is equals to F diffusion plus Fe. Now the net particle flux density will be for donor F plus and for acceptor F minus. Einstein relation between mobility and diffusivity is given as D is equals to mu kT upon Qi, where K is the Boltzmann constant, T is the temperature in Kelvin, mu is the mobility and Q is the electronic charge. So mu is equals to D Qi upon kT, which is equal to D upon Vt. Vt is the voltage. So from above equations we get F plus and F minus donor and acceptor equations as written. By continuity equation we are having del n xt by del t is equals to minus del f upon del x. So we get del nd by del t is equals to del by del x d del nd by del x minus d e nd upon vt. Again for acceptor ions we are having the equation E is very small and can be ignored. So the equation comes to a general form as del n upon del t is equals to del by del x d del n upon del x, where d is the diffusion constant, so it would be kept out from the bracket. Now we are having del n by del t is equals to d del square n by del x square, which is called Ficks second law. Now our next topic is atomic model of diffusion. In this model, the significance of the atomic model is the atomic model of different says that crystal is isotropic and the diffusion coefficient is function of doping concentration and depth level. The lattice sites are represented as minima of potential well. Each atom is at rest at 0 degree Kelvin. As we increases the temperature, the atom oscillates from its equilibrium position. If we insert an impurity atom into the crystal, the atom may sit between lattice sites in interstitial position. The atom may also substitute the silicon atoms in lattice site. Kinds of exchange. There are two kinds of exchange according to the atomic diffusion model. First is direct exchange and second is vacancy exchange. In direct exchange, at least 6 bonds must be broken, while in vacancy exchange, only 3 bonds must be broken, as shown in this figure. So vacancy exchange is preferred for substitutional impurity. So this is all about atomic model of diffusion. Thank you.